For many decades, astronomers around the world have watched one of the most luminous and mysterious stars in the night sky, Betelgeuse. This immense red supergiant, located at the shoulder of the Orion constellation, has long stood out due to both its sheer brightness and its unusual characteristics. Massive and inherently unstable, Betelgeuse exists in a precarious state on the edge of gravitational collapse. Researchers have always been aware that the star's life would end in a violent supernova. What remained uncertain was when that final event would occur. Now, for the first time, evidence is emerging that this long-anticipated transformation may be underway. Recent observations using the James Webb Space Telescope have provided what may be the first direct visual record of a supernova beginning. In real time, these observations mark an extraordinary scientific milestone. They capture the early phases of a stellar death, a cosmic upheaval of unimaginable scale, revealing the raw, uncontrolled energy that drives the life cycle of stars and, by extension, the structure of galaxies and the matter within them. This event is not simply another celestial occurrence recorded by modern instrumentation. It is potentially one of the most significant astronomical discoveries of our era, the closest supernova ever detected by humanity, taking place within our own galactic neighborhood. The implications for science are profound. Betelgeuse is no ordinary star. With a diameter over 700 times that of the Sun and a mass nearly 20 times greater, it has long drawn scientific attention. In late 2019, Betelgeuse underwent a puzzling dimming event, growing markedly less bright over a period of weeks. This unexplained change in brightness prompted global speculation and renewed scrutiny as researchers debated whether the star's collapse had already begun. Now, the Webb telescope, with its exceptional infrared sensitivity, is revealing phenomena never before seen. Unlike other telescopes that struggled to pierce through the surrounding dust and gas, Webb has provided unprecedented clarity, exposing a range of indicators that suggest dramatic internal instability. Among these findings are intense discharges of energy and vast upheavals in the star's outer layers. Surface material appears to be boiling, shifting violently, and interacting with chaotic magnetic fields that twist and spiral unpredictably. These are not normal stellar fluctuations. The changes suggest that Betelgeuse is undergoing a major structural transformation, one associated with the final stages of a massive star's life. Scientists now believe we are witnessing more than just irregular surface activity. We are seeing a star in the process of dying. 4 months, the Webb telescope has maintained its focus on Betelgeuse, cutting through the dense cloud of circumstellar material and revealing dynamic behavior previously thought impossible to observe directly. The data being collected is nothing short of extraordinary. Massive convective bubbles larger than the planet Jupiter are erupting across the star's surface. High-temperature plasma is escaping into space at incredible speeds, reaching thousands of kilometers per second. Within the deeper layers of the star spectrum, scientists have detected what appears to be a shockwave propagating outward through the star's envelope. This could mark the precise moment when internal collapse has initiated the outward dispersal of matter, a hallmark of the beginning of a supernova. Unlike distant stellar explosions that appear only as brief flashes in remote galaxies, this event is occurring a mere 640 light-years from Earth, giving researchers an unparalleled opportunity to study the anatomy of a supernova from the beginning. This proximity allows for detailed investigation into the physics of stellar death. Scientists can now observe how the core of a massive star collapses under its own gravity, how elements are forged in the heat and pressure of the explosion, and how the resulting shockwaves interact with the surrounding space. Such an event provides insight into the process that creates many of the elements essential to life, including carbon, oxygen, and iron elements that constitute planets, biological systems, and even human bodies. The implications extend far beyond the fate of a single star. What Webb is revealing is central to understanding how galaxies evolve, how new stars and planetary systems emerge from stellar remnants, and how the universe continually renews itself. With the precision of modern instrumentation, for the first time in human history, scientists may be able to construct detailed models of a supernova's development as it unfolds in real time. These models could lead to new predictive capabilities, helping researchers recognize the signs that a star is approaching collapse well in advance. This ability to anticipate stellar deaths could fundamentally change how the life cycles of stars are studied and catalogued in the future. Moreover, Webb's instruments have captured more than visible changes. The telescope has detected bursts of high-speed particles and energetic radiation escaping from the star's atmosphere, influencing the surrounding environment. These particles are heating nearby gas and disturbing the vast cloud of dust that encircles the star. One of the most compelling findings, however, may be a faint but detectable shift in the fabric of spacetime itself. A subtle gravitational ripple has been recorded, suggesting a possible link between this stellar collapse and the emission of gravitational waves. If verified by independent observation, this would be the first time a visible supernova has been correlated with gravitational wave data, potentially offering a groundbreaking new perspective on the relationship between matter, light, and spacetime. Still, one of the greatest unanswered questions remains: what will be left behind after Betelgeuse's final collapse? The core of a massive star may form a neutron star or, if the conditions are right, collapse further into a black hole. Yet the observations from Webb hint at something more complex. The collapse appears to be uneven, with parts of the star's structure falling inward, while others are expelled outward. The star's magnetic field is behaving erratically, and some of the collapsing material seems to be drawn back toward the core instead of dispersing. This chaotic behavior has led some scientists to suggest that what is forming may be an entirely new class of astrophysical object, something that bridges the gap between neutron stars and black holes. Such an entity has been hypothesized for decades, but never observed directly. The current event may offer the first opportunity to study it. Given the relative closeness of Betelgeuse, some have raised concerns about whether Earth is at risk. Fortunately, despite its dramatic scale, the star is distant enough to pose no immediate threat to life on Earth. The supernova's radiation, while powerful, will diminish over distance. However, its effects may still be felt on a cosmic scale. Gamma radiation, electromagnetic pulses, and high-energy particles will sweep across space, possibly reshaping distant clouds of dust, altering interstellar structures, and changing the way starlight reaches our planet. Over time, such changes could influence astronomical observations and models, shifting our view of the universe in subtle but significant ways. Ultimately, Betelgeuse reminds us that even the most massive and ancient stars are not eternal. All stars, no matter their size or brilliance, will reach the end of their lives. Yet in their death, they sow the seeds of new beginnings. The explosion of a star like Betelgeuse will enrich the surrounding space with heavy elements that may one day coalesce into new stars, planets, and perhaps even living systems. Among the most fascinating findings from Webb's data is the identification of rare elements such as technetium and yttrium. These materials are only produced in the most extreme conditions, such as those found in supernovae. Their presence provides an important clue about the cycle of matter in the universe, from ancient stars to emerging solar systems, and even into the biological molecules that form life. This moment is not solely about Betelgeuse. It is about the broader story of transformation that underlies the cosmos. The star that once blazed brightly in Orion will no longer shine in its original form. In its place will be a cloud of glowing debris, a visible reminder of stellar death, but also of cosmic rebirth. The data left behind will endure, offering researchers a new foundation upon which to build our understanding of astrophysics. In the silence of deep space, a massive object collapsed, but in doing so, it conveyed a message carried through light and energy, one that predates the Earth itself and will resonate long after our time has passed. As this event continues to unfold, one question remains: what more will the universe reveal? And are we prepared to perceive it when it does?